Welcome to the Cow Corporation's series of videos about software engineering. The topic of this video is STL searching algorithms. Before proceeding, make sure that you have already watched these other videos first. You can find the largest item in a collection by calling the max element function. You can find the smallest item by calling the min element function. The smallest and largest are returned together as a pair by the min max element function. If a collection has multiple of the largest items, then the first one is returned. The meaning of largest depends on the provided sort object. For this standard less sort object, largest actually does mean largest. This find function returns an iterator to the first item in the collection having the requested value, or it returns a null iterator if none of the items do. A different function is used if you want to search for an item that has a different criteria other than just equality to a certain value. You can invert the meaning of the callable object's return value. Assuming that this collection is already pre-sorted, according to a programmer-specified sort object, this binary search function determines, in logarithmic time, whether or not a given value exists in the collection. This includes function is the same as binary search, except instead of considering just one test value, this includes function considers a whole collection of test values. As a result, this includes function is essentially testing if one collection is a subset of another collection. If the programmer-specified sort object is omitted, then it will default to less. This is another form of searching for a bunch of values. This time, instead of the second collection being a potential subset, it is a potential pattern. This example pattern is 11, then 22, then 33. So, the find end algorithm searches for some occurrence of 11 in the main collection, which is immediately followed by a 22, which is immediately followed by a 33. Our example collection has two such occurrences of that pattern. So find end will return the latter of those two, returning an iterator to the location where that latter occurrence begins. When this algorithm is considering whether an item from the pattern matches with an item from the main collection, we usually want to define that matching as those two corresponding items being equal to each other. That's what our equals pattern callable object is doing. But that callable object could have done some more complicated kind of test. If you don't specify any callable object to the find end algorithm, then it will default to doing a comparison that works the same as our equals pattern. Yet another form of search doesn't consider the second collection to be a potential pattern. Instead, this find first of algorithm considers it to be a set of options. Find first of returns an iterator for the first occurrence of either 2 or 22 or 222. The adjacent find algorithm returns the first occurrence of repetition in the collection. And finally, the mismatch algorithm takes two collections and returns the first occurrence where their corresponding items are different.